Hello! In this episode of Finno-Ugric Machining, we are going to, we are not going to weld again. Instead, we are going to look into a tool which I received from a friend in Netherlands or Dutch or Holland, whatever that is. Anyway, this he's a long time subscriber who wanted to donate me this tool. And I looked into it and I really don't have one. Well, I do have, but I have one that is, a tiny one, really tiny, you will see. And then I have one that is or 40 centimeters in diameter and weighs 40 kilograms, and it's unmanageable in size, and it doesn't fit anywhere. I think that will be in the next pile to go into a scrapyard. So first of all, of course, thank you, Huib, for this donation. This was really nice, and let's see what it is. And how to use it, and how to set it up, etc. Yeah. Let's see. So now let's go into the actual subject. Okay. Well, if you wonder about my voice, it's because I took this antigen test and it got 2 lines, which means that I'm pregnant. I had this COVID-19 infection. I can tell it's not a normal influenza. It's a little bit worse. And how would I say? It's that's one reason why this episode has delayed a little bit. I was resting because when you get this infection, please rest. It can take a really bad turn if you don't obey what your body is telling you what to do. So rest. Back to this this round table, turning table, Rundtisch, whatever this is in English. Anyway, it has it's typical rotating dish. I'll take my sleeves up. So it's a typical round table, turning round table. Okay. You have first of all a quite steady base on which sits a table that turns, hence turning table, and you can turn it to some exact positions. Manually, there is a graduation here, and then you have a pointer, and you can turn it to any position just manually like this, and then we have here on the sides. One is here, and another one is here. So these are locking. So you can turn it to some wanted position, like let's say exactly 296 degrees. Here you are, and then I lock it here. And now I can do my whatever I. These are sometimes a little bit cumbersome to. Oh. The design of these is not very good. It's they are not easy to access. Sometimes they go so 96 degrees, and let's lock it there. So now you cannot turn it. It locks it quite readily to the base, and then you can do your turning, and then you can unlock it and choose another position, etc. By this you get an accuracy of about 1 degree. I suspect, well, it depends on your site, but 1 degree is, the graduation is 1 degree, and getting it more accurate than that, maybe ½ degree accuracy, but no. Let's say it's within 1 degree when you use the graduations here. Okay, and then there is another method. It's about this here. The where is my zero? Oh man, there is the zero. So this is so-called a direct indexing. When you put it like this, it locks like there. Now this is locked into 0 degrees, and this is you can repeat with this one. This is sometimes really fancy. So yeah, so when you lock it there, it is there. It's now 0 degrees, and this goes on 50 degrees intervals. So you next one would be 15 around there. Let's see. Yeah, 15, 30, of course, 45, yeah, is it 60? Yeah, 75, etc., and 90, and so on. So there are altogether, there is a gear inside, and this has one tooth that engages with that gear, and that gear has 24 teeth in it. So, so therefore, it's divided in a, it's very ordinary system. So, and it's quite accurate, actually. So, the indexing alone is quite good, but you should still lock it before milling. Okay. And then that's one thing. So you can rotate your work to any nice position and do milling, rotate to another position, do milling, etc. This is good for bolt circles and whatever you do. So that's one. Another thing is to mill round forms on your workpiece, and this is done by clamping your workpiece again in here, and then you rotate this while milling. And well, you could probably rotate it by using your hands, and well, sometimes you might do that, especially if it's very sensitive and very delicate work you are doing. It's not a good bad idea to do it by hand rotating it. But if you are taking deeper cuts or a little bit or are a little bit more heavy, so then you probably want to use the existing system here. So this here, when you engage it, this rotates, as you can see. Yeah, whip. It didn't rotate like that when I got it. Yeah, this was a little bit. There was a reason why it was so stiff, and actually it's the that's a design failure. This device had a design failure which made it so that the locking mechanism of this was not good. First of all, it didn't lock completely. It was impossible to get it locked completely. And then when you freed it, it was still a little bit locked. So you couldn't get it like free, totally free like it is now. You can rotate it with 2 fingers, or you couldn't get it locked. Now, and the reason I will show a photo, it's this corner here. They left a little ridge here. I don't know why, maybe they didn't have a suitable slitting or something, but they didn't mill it. This piece is now loose. I mean, this piece here is now loose, and it's only, well, it's loose so that when I tighten this screw, it will actually tighten it. But earlier there was a 2 millimeter wide ridge here, which prevented it from tightening. Uh, I don't understand why they left it there, but there it was. So when you there is a warm gear inside, which engages when you rotate it to that direction, and then you can lock it. And now this locks really easily just by one finger like that, and no more force needed. Now it's completely locked. Yeah. And now you can turn this. And well, this is quite near the traditional dividing head system, so that the gear ratio 40 turns from this makes this turn once. Okay. And then you can put here a crank like this. There you are. And then you can crank it. And yeah, of course, this has a lot of backslash. But you can actually, if I would use this, I would even so slightly lock it, just a little bit. So, no, that's too much. You have to be really careful. No, yeah, okay. But you can try to overcome that backslash, and of course, when you are milling, you don't do climb milling with this one. It will strike back right away. There is about, how much is this slope here? It's 1 degree. 1 degree backslash. Well, it's pretty normal for these type of turning tables. So that's one. So now you can rotate it however you wish, and make those round formations on your workpiece. Okay, that's one. And then now comes the fun part. Well, again, did you know this? I didn't have anything here. I had to make a modification for this one because it was not possible to use this option without dividing plates, and that was, to my feeling, that was a little bit cumbersome. So I have here C-clips, which now make it so that this is now locked into place in both directions. Earlier it went down and did whatever it did there, and it was not a good thing that it did down there. And now, okay, and then this is about the round table. You can use it like that. That's the main usages of a round table. But you can use this for dividing as well, because this one came with these dividing discs, which you put here, like that. And then you have a place for a screw here somewhere there down. I only put one screw in this case here. Hopefully it goes there, yeah, like that. So now, then we had this is so-called sector arms, which are used when you do divisions. These are not absolutely necessary, but these are very good aid in remembering things. It's remembering things. And then it had this, and the intention was somehow to have here something that pushed it against this plate and made it so that it wouldn't turn while you're turning. But what happened was that it was actually turning. When you turned the crank, the sector arms followed your crank. That's not what you want to happen. You want them to stay in place. So I was thinking what to do about this thing, third modification is here on the back side. There are, if you can see, there are 3 round objects here. These are tiny neodymium magnets. These are not super strong, luckily, and they are glued here just by some heavy-duty retainer compound. It's Loctite something, and yeah. And now when I put it here, the magnets keep it in place, but it's a little bit too tight. So there is a very thin aluminium ring which lifts these a little bit above the surface, and now it's really good. It's not going anywhere, but it's still like easy to turn. So yeah, and then you, of course, you have your crank, and you have to remember this guy here under. It's essential here. This is made of some pop metal, maybe zinc cast. So there you are. So now you can do indexing. And there are 2 more discs, and I haven't looked into the divisions yet, but I believe those are probably enough for my needs. If I need another, I will take out my real dividing head and make one more. So if I need to do such a division here. And now you can do your divisions, like let's assume that you start from here, and then you have to go like 1, 2, 3 turns, and then a little bit more, and then you move this again like that. That's the way how you use the sector arms. And yeah, okay, so that's the dividing head. It has some fancy issues, like you cannot place it too far into the table. You have to keep it level to the edge. So I need to clamp it from the corners, from one here, and one here. Maybe one here too. I have the clamps, so no trouble there at all. But it's while using these dividing discs, it's not very good because it just doesn't go, as you can see, on top of the table. And yeah, okay. So yeah, this might be a Chinese one, but this is not even near the worst ones I have seen. It doesn't have any sharp corners, which was already a very nice thing. Not even here where you usually have them. So they have done something like finishing this one. So I believe this is, one more time, thank you Huib for this one. And now let's see the other item that came with this. And yeah. So, it didn't stop there. The package from Netherlands, it contained another item as well, and it was a chuck. Well, apparently this could be used on top of that rotary table, but yeah, it could be, and I might also use it, but there is a few things about this. Originally it had this one attached to another plate, which was attached to this plate, making it all a little bit high. And if you think about this, These are, by the way, soft jaws. If you think about these, they are already a little bit high, and so it piles up. So, well, what I need to do here is to think how to attach this chuck into that rotary table. And now if we look in on the back side here, there are three attaching screws, and then we have this recess here, which is a good indexing surface. And then we can put this that way here. Those 4 holes here are suitably aligned. For some reason these 4 holes are not. They are not in good places. I don't know why. They are original holes for this piece, and maybe it was the intention to, in its original use, to have it located in only one way. Well, yeah, okay. So, what we need to do is to take something off from this surface. We have about 10 millimeters down there, so we can take it down about here, and then make this recess here so that it fits perfectly here. And then we need to do something for those holes which are, or those threads which are M8. So, well, yeah, well, and this will be done in the lathe. So let's go and just do this. So, well, now that we have the recess for the chuck here, the place for the chuck, we need to have places for the mounting screws. And there will be 3 of them, and they are 120 degrees apart. And I'm using the rotary table itself for pointing, making the places. I cannot use this for boring because drilling, because we have the plate there under. But I can, what I can do, I can pinpoint the places. So, well, let's do just that. Okay. So now, here is now the rotating table. That's the one that we just milled the part for adapting the chuck, and here is the chuck. So in principle this goes so that this goes on top here, like that, and then the chuck goes on top of everything like that. And well, it's a little bit high to my liking, but well, okay. So let's see how these things fit together. So first things first, let's put this here, and then we have the back plate here, which goes here like that, and then we have 3 M8 screws that go somewhere there, like that, and like that. No trouble at all. They go there. And you have to be a little bit careful when tightening these, so that you tighten them equally. So that you, and especially that you don't over torque them. Okay, it's there. And now let's see. Next space. I try to tighten them as equally as I can. Yeah. There you are. That's it. And now, as you can see, the back plate is there. So then we have just ordinary M6 screws which go here. My intention was to make special screws for this one, but now, as I can see, these screws are actually well suited for M6 bolts as they are. Maybe that was the intention as well. So now this should be placed on top of that. That's not easy to do. You can do it if you hello. This should rotate. Yes, it does rotate a little bit. It's not very this one is okay. This is very yes. Okay, and then we have a washer there under each of them. Yes, and now let's see how oh, this goes. Good. All I need to is to have them on. This is not very... Okay, there you go. First one is there. Next. Okay. And now, of course, this should be dialed in a center. As you can see, there is a lot of slop, which is good, because now you can center it, but I don't do it at that. This is just, I will take it apart one more time, and there is a good reason for that. Then you just tighten these again equally tight, not very hard, then you have your chuck mounted here. Well, it's not completely tightened, but there it is now, and you could dial it in from this rim, actually. It's concentric with the center. Oh yeah, and then you have a chuck mounted on here, and there is of course this chuck key, which can be used to operate the chuck, and then we have this has a set of jaws which these are soft jaws, and they are not in a very suitable form for operations which I intend to do here. I think I need to, these are soft jaws, so I can actually reform them to suit better for this purpose. So, and as you can see, it's pretty high. So this is really, it all adds up. And now I probably have only about this much here on the top for my workpiece. So, well, there are a few solutions for this. First of all, there exists 4-jaw chucks which are really low profile. So that's one solution, and they are suitably sized for this milling table. And then you could use no chuck at all. You could just use the table. Okay, that's also one option. And then you get this much of over 100 millimeters of more space between your milling head and your table. And yeah, okay. So I think the vertical dimension of this one is a little bit too much. That's just my opinion here. You might get, at the moment, I have about, when I look under my, there, I have about that much more. This can go that much more down, and then the maximum is reached. So I have very little space here on top of this. So this milling machine, yeah, okay, is not very well suited for high objects like this one. There is also another issue with this kind of pile-up. The farther away you are from the milling table, the more unstable it becomes. So this is like already quite a lot. So yeah. Well, I think I'm not going to use the chuck with this one, only if needed. It's how would I say? It's too much. Okay. So, and then I promised to show you something that I really do have. A rotary table. I have one, but when you see it, you understand why I have not been using it. It's this micro version. It's this is also Chinese, and this has the benefit of being able to be mounted vertically, which is really good, as then you can turn the milling head, you can turn it vertical as well, and then you can have quite a lot of things here. But this one doesn't have the indexing system at all. There is actually no indexing systems in this one. yeah, okay. Well, there you are. So the conclusion about this one is that I will use it as a rotary table only without the chuck. I will clamp my workpieces directly to the table. That is probably the most efficient way, and it allows most space between my work, so to say. Yeah, okay. Well, in the next episode of Winnow-Grip machining, we are going to make one part, and I try to make it with this this rotary table. There will be a it's a coupling between the motor and the rotary compressor, and this coupling must be flexible somehow, and it consists of two parts. One goes to the motor and one goes to the rotary compressor shaft. And then there is a flexible joint between those. And I have a little bit of plan how to do this. But this will be in the next episode of Winnow-Grip machining. Till then, bye!